Let's say I have a number which I have rounded off to one decimal place, and after rounding off, I have 3.6. Now I did not tell you the real number. So what could the real number be? Let's use the number line to understand this. So this is the number line, or 3.6 is here. Let's take below 3.6 of one decimal place number, which is 3.5, and one decimal place, but on the upper side, one up. So we have 3.7, right? Now, let's take the middle of 3.5 and 3.6, which will be 3.55, right? And 3.6 to 3.7, the middle will be 3.65. Now, why did I take these middle numbers? Let's understand something. From 3.55 to 3.6, I have these numbers 3.51, 3.52. We can continue like this to 3.59, right? 54, 5, 3.56, 57, 58, and 3.59. So I have the digits. Now, if I round off this number to this number, they will be rounded off to 3.5, which is not my number, right? So they cannot be counted. But if I round off any number from 3.55 to 3.59, it will be rounded off to 3.6. Now we don't know the real number, right? Let's say my real number is x. Okay, it represents a set. So the number can be on the lower side, starting from 3.55, it can be up to 3.59. So my number can be either 3.55 or greater than 3.55 in this respect, right? From here to here. Now let's talk about the upper side. If we go from 3.6 to 3.7, again we have 3.61, 3.62, 3.63. Like this, we can go to 3.69, right? 5, 6, 8, and 3.69. Okay, now if I round off 6.1 to 6.4, below 3.65, I'm gonna get our rounding number, which is 3.6. So they're correct, they're okay. But if you're starting from 3.65 to 3.69, if I round off any one of them, I'm gonna get 3.7. So they're not the number. So my number x must be below 3.65. So I can write it like this, 3.65. Remember, we cannot use the equal sign here, because if we use the equal sign, 3.65 will be rounded off to 3.7, which is not correct. We want our rounding number, which is 3.6. So it must be below 3.65. Even if it's 3.649, that's fine too, but it has to be below 3.65. Now, we found this range. In this range is our actual number, which has been rounded off to 3.6. This is called error interval. Error interval. Okay. Now, the lower portion we took, 3.55, this guy is called the lower bound. And the upper limit we took, 3.65, this is called the upper bound. So the easier thing is to take the middle number between your lower and the main number that you have been rounded off, and then use the equivalent greater than sign, because if this one can be rounded off to our actual number, but on the upper side, the middle thing we are going to take from the upper side, that cannot be written as equal, because in that case it will be rounded off to the next number. So that is how you can calculate your error interval and lower bound and upper bound. So in our example 1, we have a question where we have a number x which has been rounded off to 2 decimal place, and our answer is 6.72. We have to find the error interval for this one. So first of all, we need the number line. So our 6.72 is in the middle. We're going to take one number below 6.72, but it must be 2 decimal place, so it's 6.71. And for the upper one, we will have to take another one, 6.73. One up but 2 decimal place. Now the number between 6.71 and 6.72 is 6.715, and on the upper side we have 6.725. So if any number is 6.715 and above but below 6.72, we can round it off to 6.72, and any number below 6.725 can be rounded off to 6.72, right? Okay, so for our error interval, we will have to take 6.715. If our number is this one and greater than this one, we can round it off to 6.72. But on the right side, on the upper side, the number must be below 6.725. Because if the number is 6.725, we will round it off to 6.73, not 6.72, so it will not match our answer. So our number x must be between this one and this one. So this is our lower bound and this is our higher bound. Our number must be between these two numbers. So this is our error interval for this question. By the way, if you need help with IGCSE chemistry, I have a whole playlist. You can just press the I button and check out that playlist. It will be of great help. Now, in our second example, we have a number y which has been rounded off to two significant figure, and our result is 18,000. Now we have to find the error interval for y. Now let's draw the number line. So our 18,000 is in the middle here, and the lower number for a two significant figure below 18,000 is 17,000, right? So let's say 17,000 is here, and the upper one will be 19,000. So this is our upper one. Now what's below 17,000 and 18,000 is 1,000, so we're gonna have 17,500, and for the upper one we're going to have 18,500. Now let's make our error interval. This is our lower bound and this is our higher bound. So this is our number y, and as we have seen in our past examples, it must be equal or greater than this one. Our y will be equal to this one or greater than this one, because any number between here to here can be rounded off to two significant figure, and 18,000 will be our answer. So 17,500 is equal to or greater than y. Okay, now for the upper one, as we have seen, we can only use the smaller than sign, not the equal sign, because if it's equal, 18,500 can be rounded off to a two significant number, which is 19,000. So we cannot go to 18,500, it has to be below 18,500. And just like that, you have found error interval again for significant figures. Using this method, you can actually use any significant figure and find your answer. For our example 3, we have another question where there is a number z that has been rounded off to nearest 50. And the result is 8,350. We have to find an error interval for z. Let's draw the number line. So in the middle, we have our number, result 8350. Now, the lower number to the nearest 50 or 8350 is 8,300. So we are just getting lower than 50. So 8,350, the lower will be 8,300. Now, on the higher side to the nearest 50 will be, we have to add 50 here, so you're going to get 8,400. Right? Okay. Now it's time to get the lower bound and the upper bound. So what's between 8,300 and 8,350? We'll have in the middle 8,325, right? It's in the middle. And what for the other upper one? We have 8,375. This is between this one and this one. Okay. So we have our lower bound and we have our upper bound, and just like that we can find our error interval. It must be, the number must be 8,325 or greater than that, but it will be lower than 8,375. So you can just use the lower and upper one and you can find your error interval for anything just like this one. In our example 4, we have a number which is rounded off to nearest integer. The number is 115 and it's assigned by s. So we have to find our error interval. Let's do it. Again, we are going to draw our number line and our result in the middle. It is to the nearest integer. So we have to find the lower integer than 115, which is 114. And for the upper one is 116 to the nearest integer. So just we go up just by one number and we have 116. Now what's between 114 and 115? There is no integer. 114 and 115, if you find what's middle of it, you're gonna find 114.5. And for that one, you're going to get 115.5, right? If you're confused about it, you can add them and divide by 2. You're going to get your average there. It's basically the average, what's in between. Now we know that this is our lower bound and this is our upper bound. Anything below 115.5 can be written as 115 as the integer, and anything 114.5 and over that can be rounded off to nearest integer, and we can write it 115. So our answer is going to be 114.5 is greater than or equal as smaller than 115.5. We cannot use an equal sign here, as we have discussed earlier. In our example 5, we have a word problem where we have been given a water bottle. The capacity of that water bottle is 340 milliliter to the nearest milliliter. It has been rounded off to the nearest milliliter. We have to find the error interval for the capacity of the bottle. Now, again, let's make the number line. We have our rounding of number, which is 340. This was 340 ml to the nearest milliliter, right? So what's the nearest milliliter on the lower side of 340? It will be 339 milliliter, right? And to the upper one will be 341 milliliter. To the nearest milliliter just says the nearest integer, right? Okay, now let's find the lower bound. What's between 339 and 340? It is 339.5, right? And between 340 and 341, we're going to get 340.5. Okay, now we know that this is our lower bound and this is our higher bound, upper bound. So for capacity, let's say it is C. Capacity can be anywhere between 339.5 to 340. Then we can round it off to 340 to the nearest milliliter. So it will be 339.5 smaller than or equal. Any number starting from 339.5 to 340 will be rounded off to 340. Now for the upper one, as we have seen, this will only be lower, because if it was 340.5, we would have rounded it off to the nearest milliliter, would have been 341, which is not the result. So to get 340, the number must be below 340.5. And here it is, you have found your error interval for the capacity of the bottle. So the capacity of the bottle is anywhere between 339.5 to lower than 340.5. That's it for today. I think your error interval calculation is very clear now. You can find error interval basically from anything. In our next video, we're going to see how we can use the error interval to solve equations and find upper and lower limit of equations or any values. Thank you.